In today's video, we're going to build our very own simple blockchain from scratch using Rust. We will create a functional blockchain that demonstrates the fundamental principles. So, what exactly is a blockchain? In simple terms, it's like a digital ledger that is distributed across many computers. Imagine a shared, unchangeable record book. Every transaction, every piece of information is recorded in blocks, and these blocks are chained together cryptographically, making it very secure and transparent. That's why it's called a blockchain. All right, let's get our hands dirty with some code. First, initialize a new Rust project. First, let's take a look at our cargo.toml file. As you can see, under dependencies, we have a few libraries listed. Srd and srd.json. These are for serialization and deserialization. These dependencies help us convert our Rust data structures into a JSON and also to convert data back into Rust structures. The derive feature just makes it easier to use with our own custom data types. SHA-2 is our cryptographic hash function library. We'll be using SHA-256, which is a secure algorithm to generate a unique fingerprint for our blocks. This is crucial for the security and integrity of our blockchain. Chrono. This is a date and time library for Rust. We'll use it to timestamp when each block is created. Now let's jump into the main.rs. This is where we define the structure of our blockchain and how it works. Right at the top, we have some use statements. We're getting SHA-256 and digest from SHA-2, serialize and deserialize from srd, and some date-time functionalities from chrono. Next, we define our block struct. Think of a block as a container for information in our blockchain. Each block will have these key components. Index. This is just the position of the block in the blockchain, starting from 0 for the very first block. Timestamp. When was this block created? We use chrono to get the current date and time and store it as a string. Previous hash. This is super important. It's the hash of the previous block in the chain. This is what links blocks together and creates the chain effect. It ensures that if anyone tries to tamper with a block, the hash will change, and it won't match the previous hash in the next block, breaking the chain. Hash. This is the unique fingerprint of the current block, generated using the SHA-256 algorithm. It's calculated based on the block's index, timestamp, the previous hash, and the data it contains. Data. This is where we store the actual information we want to record in our blockchain. In our simple example, it could be transaction details, but in a real blockchain, it could be anything. You might notice derive macro above the struct block definition. This is a Rust attribute. It's telling Rust to automatically implement certain functionalities for our block struct. Serialize and deserialize allow us to convert blocks to and from JSON format. Debug lets us easily print out blocks for debugging, and clone allows us to make copies of blocks. Now, let's look at the implementation block for our block struct. Here, we've defined two functions associated with our block, new and calculate hash. Let's start with the new function, which is like a constructor for our block. It's how we create a new block. When we create a new block, we need to provide its index, the previous hash of the block before it, and the data we want to store. Inside the new function, we first get the current timestamp using UTC, now from the chrono library. Then, we call our calculate hash function, passing in the index, the newly generated timestamp, the previous hash, and the data. This gives us the hash for our new block. Finally, we construct and return a block struct with all these values. Next up is the calculate hash. This function is responsible for creating that unique fingerprint for each block. It takes the index, timestamp, previous hash, and data of a block as input. It concatenates all of these into a single string. Then, it creates a new SHA-256 hasher from the SHA-2 library, feeds in our concatenated string using hasher.update, and finally, hasher.finalize computes the hash. We then format this hash as a hexadecimal string using format and return it. Essentially, we are taking all the important information of the block, mixing it together using a cryptographic algorithm, and getting a unique, fixed-size string as output. That's our hash. Okay, we've got our block structure down. Now let's build the blockchain itself. Our blockchain struct is quite simple. It just contains one field, chain. This chain is a vector, or a dynamically sized array, that holds a list of blocks. This is where we will store all the blocks in our blockchain, in order. And here are the methods for our blockchain. First, we have the new function for blockchain. This is how we initialize a new blockchain. When we create a new blockchain, the very first block is special. It's called the Genesis block. It's the starting point of our chain, and it doesn't have a previous block. So, in our new function, we create a Genesis block using block new. Notice the index is 0, and the previous hash is set to 0 because there is no previous block. The data for the Genesis block is simply Genesis block. Then, we create a blockchain instance. We initialize its chain with a vector containing just our Genesis block. So, when a blockchain is first created, it already has one block, the Genesis block. Next, we have the add block function. This is how we add new blocks to our existing blockchain. When we want to add a new block with some data, we first get the last block that's already in our chain using self.chain.last.unwrap. Unwrap here is assuming that our chain is never empty when we try to add a block, which is true in our example, as we always have at least the Genesis block. Then, we create a new block using block new. For the index, we take the index of the last block and add 1. For the previous hash, we use the hash of the last block. This is what links our new block to the previous one. And of course, we pass in the data we want to store in this new block. Finally, we push this new block onto the end of our chain vector, effectively adding it to our blockchain. Alright, we've defined our block and blockchain structures, and how to create and add blocks. Now, let's see how we use it all in our main function. In our main function, we first create a new blockchain instance called myBlockchain by calling blockchain new. Remember, this creates a blockchain with just the Genesis block. We use mutable variable because we are going to modify our blockchain by adding blocks to it. Then, we add 2 new blocks to our myBlockchain using myBlockchain.addBlock. The data for these blocks are simple transaction strings. Finally, we loop through each block in myBlockchain.chain using a for loop and print each block. The format specifier is used to print the debug representation of our block, thanks to the derive debug we added earlier. And that's it. This is a basic implementation of a blockchain in Rust. To run this code, run this command in your terminal, cargo run. This will compile and execute your Rust code. When you run this code, you'll see the output in your console, printing out each block in your blockchain, starting from the Genesis block, followed by the 2 blocks we added with our transaction data. You'll see the index, timestamp, previous hash, the block's hash, and the data for each block. Remember, this is a very simplified blockchain. A real-world blockchain is far more complex. It involves networking, consensus mechanisms, more sophisticated cryptography, and much more. However, this example gives you a solid foundation to understand the core principles of blockchain technology. Blocks linked together using hashes, forming an immutable chain of data. If you enjoyed this video, check out other quick coding challenges on this channel, and comment below on what you'd like to build next. See you in the next video.